just a moment. So we're trying out like a lot of little improvements here. One of them is closed captions. So if I talk, you can see it show up. Yeah, pretty cool. Not my idea, but I think it's a great idea. All right, sweet. So today, welcome to class. Is this class 13, I think? Yeah, class 13 right there on the slide. So we're talking about Git and CSS. But first, a very short story. Some of you have probably heard the story about the rubber ducky. It's familiar. I'll just recap it real quickly. So legend has it, there was a junior programmer and a senior programmer. And the junior programmer would always go up to the senior programmer and ask him this long, complicated technical question. And as the junior programmer was explaining the question, they kind of figured out what the answer was. So then they went back to the desk. And that kept happening like day after day. Junior programmer walks up, tells the entire story, figures out the answer for themselves, and walks away. So eventually the senior programmer hands him a rubber ducky and says, hey, just talk to the rubber duck. You know, same difference. So anyways, you'll hear the phrase rubber ducking. That means when you're just explaining something to someone just to be able to put words to it. Right. So why did I tell that story? One, it's generally relevant to software development culture, but on Thursdays, we're going to integrate Kahoot games, and I'm taking this way too far. So the first place winner is actually going to get a rubber ducky. And there's actually going to be a button that I press, and it's going to generate a common, uncommon, or rare. So there are duckies that are rare. So it'll all make sense later. If he thinks it's silly, that's probably a fair assessment. Cool. So this will be more of an interactive lecture. This is not necessarily a change in how we're doing lecture, but more of something I think that makes sense for this evening. So later on, towards like the second half of lecture, we're all going to be interacting with the Git repository. I believe you'll have more practice doing that during Studio. And my reasoning for this is I think Git is one of those things where the more iterations you have working through the process, the more it makes sense. So we'll do something like that later. Cool. So Git review. We talked about this last class. So Git is a tool for version control. Thinking about version control, at one level of complexity, it is just the ability to save a file and to be able to go back to a previous save. Although we don't call them saves, we call them commits. So go back to a previous commit. What can we do with Git locally? That means Git without an internet connection, just on our own machine. So locally with Git, we can create a Git repository. And so that would just be in a folder, probably like a project we're working on. We can say Git init, and it'll create the Git repository. Within that Git repository, we can commit files. So that's basically saying, hey, I want to be able to restore this file from this point in the future. And so you have a commit of it. Additionally, locally, we can create multiple branches. Now, if we're just working all by ourselves on our own machine, making multiple branches, the benefit of it is not very obvious. And just because branches is a very useful tool as the project scales and as there's more people being involved. Also, in the local, no internet connection environment, we can merge branches. I don't think we talked a lot about merging branches last class. Essentially, you take one branch and you take the changes, the newer changes from the other branch, and you merge the two branches together, and now you just have one branch again. Generally speaking, the local Git process is most of what we'll be doing locally in the real world is committing files. So we can run git status to check what files have had changes since their last commit. We can add files. This is just getting them prepped to be committed. It doesn't do anything special other than that. And then finally, we can commit the files. Okay, so we're going to start transitioning our thinking into, okay, we know what we can do locally, so let's think about how this remote element plays into this. So whether or not we're interacting with a remote repository in the cloud, the we're always going to have a local Git repository. And so why is that? The reason why is if you are just working by yourself on an island without an internet connection, you have a local Git repository that only exists on your laptop. But when we are working with a remote Git repository, we have a downloaded copy of that Git repository on our local machine. And so it behaves the same way as like a local Git repository, except that instead of it just only existing on our machine, it is a copy of what exists in the cloud. And the cloud that we're going to be most familiar with by the end of this class is going to be GitHub. Cool. So, starting to think more about remote repositories. Why should we use a remote repository? A few reasons. It provides a centralized location for collaboration. That's a really big reason. Even if you have just 2 developers working on a project, having a centralized place where the code lives makes a lot of sense. Also, and this is for 1 or more developers, you can access the code from anywhere that you have an internet connection. So maybe you're developing on a laptop and a computer. Being able to have the Git repository live in the cloud is very nice for that. And it also allows you to back up your code and restore your code in case your laptop, for whatever reason, like the hard drive burns out or something. Cool. So thinking about the mechanics of this whole Git thing. So we have our local copy of the remote Git repository. They look the same in terms of like their files. The way we pull down changes from the remote repository is we use the pull command. The way we push up changes up to the cloud from our local copy to the remote repository is going to be by using the git push command. So push sends new commits up to the remote repository. That's the information we're communicating up. It's a commit which contains file changes. A pull is pulling down commits that we don't have on our local machine yet. It's pulling down commits. And the commits have file changes. A nuance of this, I'm simplifying it to think of this in terms of we're just sending commits and we're pulling down commits. But you can also pull down the entire project when you're initially setting it up, or you could pull down new branches and push up new branches. But the typical workflow is going to be sending up commits with the push command and pulling down commits with the pull command. Cool. So before we start talking about branches, I've said a lot of words. Questions so far about what we just covered about local, remote, then moving files around, or commits around, I should say. Yes? What did people do for version control before GitHub? So I've heard bad things, meaning there's other technologies that were used for version control. So the idea of version control existed before Git existed. Fortunately, I've never had to deal with any of those systems and processes, but there are people somewhere out there in the world that still are using more archaic forms of version control than Git. I couldn't tell you what they are though, but yeah. So there's been an evolution though of the version control tools. Git's been around for a long time and it's probably going to stay around though. Yeah. Good question. Other questions? Yes.
Do you always save the entire length of the history, or is there ever time you go back and delete something?
Right. So the question is, do you always save the entire history of all the different commits and stuff of a project, or do you ever sort of prune like stuff, etc.? So is that what you're asking? Right. So there are commands in Git where you can basically squash like a group of like 10 commits and just squash them down to one commit if you want to clean things up. There are ways to do that. Off the top of my head, I can't really think of like the commands that you need to run or exactly what that workflow looks like. But hypothetically, you may want to do that, and you technically could. Yeah. Usually, I think I haven't found it when I'm developing in my personal environment. I haven't found like a lot of motivation to go through that process. But yeah, cool. Other questions? Yes.
Like analogies or some ways of explaining what a good repository is? Like when you open you initialize a good repository in your machine, like a portal to the cloud, or is it
Oh, good. Yeah.
staging thing?
Cool. So, question was essentially asking for like an analogy for what exactly is happening when we're creating a new Git repository. How do we build the connection to the repository that's in the cloud? So there's two workflows. Workflow A is you start off by going onto github.com and creating a new repository and then cloning that repository to your local machine. Then everything's kind of already configured for you and you can keep, you can just work on that repository. Workflow number 2 is you start off with a bunch of local files on your machine. You run the git init command. Git init, when we create that Git repository on our local machine, it knows nothing about the cloud. That technology is actually, even though Git and GitHub sound the same, the Git technology is its own contained thing. And so what we could do is we could create it locally and then go onto github.com, create a repository, and then configure it by setting up the remote origin or things like that. I'm not verbatim remembering what the terminology is, but we can then send those files up to that repository. Generally speaking, the easiest way to set up a repository is, if you want it to be a remote repository, is just to start in GitHub, set it all up there, and then just pull it down or clone it down. To me, that's the easiest way to get things set up, right? Hopefully that's helpful. But was there another element to your question I might have missed? No, that's good. Okay, cool. Nice, good questions. Other questions? No? All right, we can move on. Branches. Okay, so this slide is going to talk about the syntax, but real quick, conceptually, what a branch is. So we can think about, we know what commits are. Commits are essentially like a history for a file. A branch is essentially you are creating a copy of the entire project, okay? And you can independently make changes to, let's say this is copy A, this is copy B. You can independently make changes to copy B, and when you send commits to this branch, they don't exist on the original copy. And so you can independently work on one copy of the project, one branch, and someone else can independently work on another copy of the project. And then later on, you may merge all of the changes together. So essentially, a way to think about what a branch is it's a version of the entire project. And a real world example would be, let's say we were working on like the Facebook app. We're a development team here. And something went wrong with the video players. Whenever there's a video on the website, the video player crashes. And so 4 of you are assigned to a team that's going to fix this bug. However, in addition to fixing bugs, Facebook wants to add a new feature. They want to add a new emoji reaction to a post. So another 4 of you are going to be working on adding this new feature, adding a new emoji reaction. So we got 2 teams doing 2 different things. So this would be a really good time to create a branch for the team that's doing the bug fix and a branch for the team that's adding the new feature. Y'all don't care about what the other person's doing, right? And so let's say this team over here, they find the solution for the bug, they implement the code fix, and then they push all those changes to the branch. Now let's say the team over here figures out how to add the new feature, and then so now we have 2 copies of the project, one with the bug fix and one with the new feature. We can merge those back to like the main copy if you have it set up with the main branch, or you could just merge them together, right? So that's sort of the, hopefully I'm explaining this in a way that makes sense, but that's sort of the purpose of how you might use branches in the real world. Cool. And also, not to belabor the point, but you may be a solo developer who is working on two different tasks on your project, and it's a little bit easier to keep those isolated. So maybe you're working on a bug fix for your project, and maybe you're working on a new feature. You can have this be on their own branches, and then when you're done with one task, you could merge that code in. Cool. So a bit of the syntax. Locally, if we start locally creating a new branch, we can run these three commands: git branch, specify the name, so git branch aardvark, for example. And then at that point, we can check out the branch. And then finally, we can run this command that says git push -- set upstream origin, and then the branch's name. That last step, because you created a branch on your local repository and it does not exist on the remote one, that last step basically sends it up to the remote one and wires that together. The second way to do this, and this is the way I prefer to do it, is to go into github.com, create a new branch, and then locally you can say git pull. It'll pull down that change. And then finally you can say git check out that branch name. To me, that's a little bit more of an intuitive workflow. Generally speaking, I prefer to do what I can do in GitHub and then pull those changes down. But these are the two workflows. Questions on these two workflows? That's a great question. The question was, can you make a branch from a branch, or does it have to come from the main branch? Right, so yes, you can make a branch from another branch, and you could do that infinitely. The main branch it's a normal branch, but it's got like an additional piece of configurations added to it. So you might be able to set a branch as being protected, and what protected means is that you can't just add code to it unless you go through a merge or a pull request process. We haven't talked about the pull request process, at least not through lecture, but it's basically a more of a rigorous way to add code to a branch. And so essentially the main branch is a normal branch that's got like additional properties, and it could be named anything, really. But yeah, you can take any branch and make a new branch, and take any branch and merge it into the other branch as long as it's not like protected or something else. Yeah, cool. Yes.
Can you explain what set upstream means?
Yeah, so I'm going to struggle here a little bit. So set upstream, what the intention of this line of syntax is to is essentially to wire the local branch that was created to the remote one. What exactly set upstream means, I'm going to struggle to explain that without Googling it. All right, cool. I can throw that into the studio review. Cool. Yeah, thanks for the question, though. Other questions? Yes.
So on the remote first, for number 4, would that be able to push it back from local to remote?
On the remote first option.
Yeah, like after you run the checkout, would you have to push it back?
No, because it already exists in the remote one. In the local first option, step 3 only has to happen one time. And then after that, if you have new commits on your local, you can just push those up to the remote because that whole setup has been configured. These two options are just setting up the branch. They're not necessarily commands for using the branch, if that makes sense. But yeah. Cool. Before we transition to CSS, other questions about Git branches, etc.
Well, not with branches and merging, but
Mm-hmm.
can you explain stash and when you use that?
Right. Okay. So the question was, what is this git stash thing? We haven't really talked about git stash. So git stash is a way to say, let's say you have some files that you've changed, and you don't want to commit them. You don't want to push them up to the remote repository. There is a command that's called git stash, and when you run it, it stashes those changes away. And when you run like git stash pop, it will basically pull those changes back in, at least the most recent thing that you stashed away. And so this is a useful tool if you want to be able to like just temporarily hide a change that you did or stash a change away. I'll try to give a real world example of when you might use git stash. So imagine if you had a project and you had a config file with a very sensitive database password in it. And as the developer, you have these passwords set up. You might say git stash, you want to stash those passwords and changes to that file. And then you'll git pull and do all the other git commands, et cetera. And then you might do git stash pop to pull those changes back in. Yeah, it's kind of you can get away with using Git without ever using git stash. It's just one of those like convenient features that they add in there for us so that we can be a little bit more flexible, if that makes sense.
It's not like reading tracks, but not permanently saving them there.
Yeah, so when we run git stash, it doesn't send anything to the remote. It's just on our local machine. Yeah. And maybe I can. That might be something to just see how it works mechanically if we have time later. Cool. Thanks. Other questions? No? All right. We will get back to Git later on this lecture, but we're going to switch gears for a little bit and talk about CSS. So this slide is essentially just to sell y'all on why I use CSS. Essentially all there is a before and after here. This is BBC website, and the left-hand side is if you basically deleted the CSS file, what that site would look like. The right-hand side is essentially the site plus CSS. And so you notice like the different color, the different layout, all these different things are essentially what we're able to bring to HTML with CSS, right? So yeah, if you're creative, visual, you like seeing things and creating things, CSS is a lot of fun. Before we talk a little bit more about CSS, there's something called inline styles. We're not going to explore inline styles a whole lot. Generally speaking, I would encourage us not to use inline styles unless absolutely necessary. To me, they are essentially like hard coding. In the world of adding styles, adding an inline style is hard coding. So what is an inline style? And an inline style is essentially, instead of setting up the style inside of your CSS file, it's going inside the HTML element and saying, these are your styles. As opposed to saying like, this is your class name, and then you set up the class name somewhere else, or the class styles. Before we move on from inline styles and questions on them, what they are, when to use them, when not to use them, anything like that. Yes?
On the previous slide, I think there's two images there.
Right.
Are those still CSS, or would they be considered part of the HTML?
So the question was, with these two images, are they still CSS or would they be part of the HTML? I don't know if I understand the question.
On the right side.
On the right side? So what we are seeing on the right side is basically just the rendering of the web page. And what is behind that is the HTML, the CSS, and very likely the JavaScript. Those three elements are influencing what we finally, the end product. So the before and after is an end product where we have no CSS versus an end product where we do have CSS. The actual content of both pages is not different, like the actual text, the images and stuff. The reason why we see all of these items right here is probably because it's hidden in this menu or in these menus up here. And so, yeah, CSS is able to do things with like the layout and stuff, but it's not doing anything with the actual content of the page. If that makes sense. Is that speaking to your question? Or?
The image that's below that date.
Oh, yes, right here. So I'm pretty sure that if we scroll down on this page, I just grabbed this example from Google. I didn't actually take the screenshot. But I would imagine that if we scroll down on this page, we would see the image. It's just that we broke the layout so much by removing CSS that the menus took up the entire screen. So you'd have to scroll down to find it. Yeah. Cool. Awesome. Any questions on inline styles before we move on and probably don't talk about them again? No? Right, so inline styles is one way to change the style of an HTML element. Another way we can do it is we can do it programmatically with JavaScript. And so here we have an example. We have HTML. At the top, we have an H1 element. The H1 element has an ID property, and the ID property is set to llama. Underneath there, we can see our JavaScript. Our JavaScript is essentially, it goes document, which is the entire HTML page, runs the command .getElement by ID, and it says, I want you to find the element with the llama ID. The reason why this should work is we shouldn't use IDs in HTML more than once. We should only have one element with an ID. They're supposed to be unique. And so it finds the element with the ID llama, and then from there we can say this llama object, which is a JavaScript representation of an HTML element, llama object .style .background color equals green. So we're basically accessing the HTML element style, and then we're accessing a property of its styles, and then we're setting the value for that. Cool. So this is not the standard way in which you will likely be setting a style. Just in the same way that setting a style inline is not going to be a standard approach, neither is doing it with JavaScript, but it is something that we can do. So questions on the JavaScript side of setting a style? Yes?
You have to do those with fonts, right?
Hypothetically, so in your HTML file, you could say, here's all my HTML, and then at the bottom of it, you could have these script tags, and inside of there, you could put your JavaScript. The other way to do it would be to import the JavaScript file at the top of the HTML file. But either way, they'll be linked if it's in one file or two. Yeah? Cool. Good question. Other questions before we move on? Yes?
What would be the benefit of style from JavaScript?
Right. So when you write a CSS file, it loads up one time when the application runs, most likely. It loads up one time, and all of those values are set. You can't change them on the fly. A nice thing about setting styles with JavaScript is if you wanted it to do something programmatic. So for example, like let's say you got a user input, and just to be ironic, every time that they typed in the word dog, it would sprinkle dog emojis all over the page or something like that. You might be able to accomplish like some unique styling with JavaScript if you want to do it programmatically, meaning something that's happening dynamically versus something that just is set up when you initially create the project. Yeah. The dog emojis is probably not the right example, but yeah, pretty much it's a dynamic versus static issue. Cool. Good question. Let's move on. Right, so this is CSS syntax boiled down to its core elements. I think, in my opinion, this is a really good simplification of how to write CSS syntax. In the orange, we have a selector. The selector's job is to match with the elements that we're trying to change the styles of. So the selector could match with an element's ID, and it will set the styles of the ID. It could match with a class name, so we'll set the styles of every HTML element with that class name, etc. So the selector's one job is to match up with whatever element we're applying the style to. Selectors, you can get real specific with them. There's a lot of little syntactical nuances if you want to get advanced with CSS, but that's still its one job. The property, if you'll notice, after the selector, it really looks a lot like a JavaScript object, and it's got the same key value pair type of a setup. So the property is whatever style or styles, if we have multiple properties, that we are wanting to set or change. And so the property could be something like color or font size or whatever else. And then finally, the last bit of syntax we should know about is the value. And so we have the property, and then we set the value. So for color, we might set the value to green. For font size, we might set it to like 10 pixels or some other measurement. And so generally speaking, all of CSS syntax is essentially boiled down to this, these three elements. And here, these are example selectors. Actually, I haven't asked y'all a question in a while. Can someone tell me? Well, it kind of already says. I was gonna ask if you tell me what each of these are intended to select, but it's kind of on the slide. So, yeah, class, property, and element. Here's examples of properties and values. Kind of spoke to a few of these. And so we're about to transition to where we're doing something a little bit more interactive, and we're all going to be working with the same GitHub repository. Before we do that, there's going to be less of an emphasis on CSS and much more of an emphasis on Git for this next part. So questions about CSS while we're here. Yes.
Curious about when you use a class
Versus using a what? An ID. So the question was, in CSS, when would you use a class versus an ID? So great question. If we remember, IDs are unique. So ideally, an ID should only match with one element. A CSS class, you could add that to multiple elements, like 10 different, 100 different things. And so a good use for a class is when you want to add it to multiple elements. And an ID is when you want to target a very specific element. And then finally, if you notice like the element thing, that would be like you could select everything that's like a P element, like a paragraph element, or everything that's a heading element, like H1. You could select all of the elements like that. And that would be good for just general configuration of how your web page appears. And then with class, you could target maybe certain ones of the headings or the paragraphs. You want to maybe say 3 of them and make them look different. And properties, like you want to make one of them look different. And then all of these, with class and properties, these should correspond with your HTML. So if you write this CSS class, you'll need to make sure that in your HTML, that the elements that you're trying to change, they have either an ID property or they'll have a class property. Right, good question. Other questions? Do you have a question?
I was just curious, what are other style sheets? Does anybody use anything other than CSS?
So because the question is, does anyone use anything other than CSS? The boiled down answer is no. The more elaborate answer is first off, the reason why HTML, everything in the web world boils down to HTML, CSS, and JavaScript is because that's what the web browsers, what they're equipped to handle. And so there's a lot of other technologies that might be generating the HTML or generating the CSS or generating the JavaScript that's not JavaScript, But essentially, it kind of ends up always boiling down to those 3 elements. Additionally, there are other CSS tools, like there's something called Sass. It's like SCSS, and it's additional. It's like it has different syntax in CSS, but even that, when you use it, it gets compiled down to actual CSS. So the developer, they don't see CSS, they see this special Sass syntax. But yeah, good question. Thanks. Cool. Let's move on for time's sake. Right, so what are we about to do? So we are going to be writing code, interacting with Git. Be sure to ask questions during the lecture demo. The goal is, one, to get practice, but more to kind of maybe expose questions that we might have about Git that we don't realize until we're trying to do something that we don't know how to do. So the one thing we won't really have time for is troubleshooting complex issues. So for example, if you don't have a GitHub account set up and you're not sure how to do that, we probably won't take time to do that. But we will take time to answer like questions about like syntax and different things that come up. Also, remember what Ms. Frizzle always said, take chances, make mistakes, get messy. Cool. More practically speaking, we are going to clone a repository I already have set up. create a new branch. Everyone who's participating, y'all are going to create a new branch for yourself. Then we will pull down the code, open it in VS Code, and then we're going to edit the HTML file and basically add our name there or gamer tag, whatever you want to add, as long as it's appropriate, right? And then if you like, you can also edit the CSS file if you want to style your name a certain way. And then finally, we will commit the changes up to the branch and push the changes up to GitHub. Right, so there's a lot of steps, so we'll try to keep an even pace here. Let me send y'all the project. So I'm going to add this to lecture slides, because that's a nice central location to add all this stuff. All right, so step one, y'all can follow along if you can here. So step one is we open up the Git page. This is where we should all be. And I'll actually pause here for a little bit, just so we're able to set things up. The next thing that we are going to do, this is probably a better link to share. Give me a second here. Cool. So the next thing we're going to do is we're going to clone the project. Now, if you have not created an SSH token, the SSH token is not going to work for you until you set that up. Generally speaking, the SSH token is something that you generate on your local machine. You create a new SSH token on your local machine, and then you basically end up putting the public key to your SSH token inside of GitHub. There's directions online that you can follow, and may or may not be in the workbook as well. So if you don't have that set up, you can try using the HTTPS method. I do have SSH set up, so I'm going to copy that link. They're essentially going to be doing the same thing, practically speaking. So let's copy the link to clone it. And then for Windows users, we'll start at git bash. For Mac users, you can just pull up your terminal. And Linux users, just your terminal. I don't know if we have any Linux users, but you never know. All right, so I like to keep everything in my projects folder. It's a folder I created. You can clone this wherever you like. Because I already cloned this project, I'm just going to create a new one here called live demo. You don't need to do this step. Let me make this easier to see. All right, so when you're ready to clone the project, we can say git clone. Git clone, and we can paste the link, which is not succeeding for me. Give me 1 second here. I'm going to try to copy it manually. Git clone. There we go. This is what it should look like. Press enter. And then we gotta wait for the network connection to go ahead and clone this for us. Now, once we're here, notice that we are not inside of the project that we just cloned. So we just pulled a remote repository from GitHub. We brought it down to our local machine. We haven't had to run any other git commands. We haven't had to say git init or anything. But notice if I do ls, we're not in the folder, so we're going to need to move into the folder. So cd I was here. Now we've made it inside the Git repository. You may have a clue in your terminal where you can tell that you're inside the Git repository because it says that we're on the main branch. So if I say ls, we can see we have an index.html file and then also a CSS file. So now, I should pause here. Any questions, any hangups? Getting to this point for everyone who's following along. No? Cool. All right, so the next part is we're going to create a new branch because we don't want to add changes directly to main. We want to create a different branch to do that. So let's pull up GitHub again. Now, I don't see a new branch button anywhere. This drop down right here, this is for all of our branches on this top left-hand corner. And so once again, I don't see a create a new branch button. However, if I just type in a name that doesn't exist, a branch that doesn't exist, and then I have a button now. Create branch McDev from main. So we're creating a branch from main. And so now I have my own branch. So go ahead and add your own branches inside of GitHub. If it doesn't give you, if you have like a permissions issue, let me know. That might be something I need to fix on my end. But I think it should allow you to do it. Refresh and hope to find other branches in here.
It's not actually saying anything, it just says nothing to show. It doesn't give us the option to create.
Okay. From main, if you type.
Yeah, if you just type it in, just says nothing to show.
All right, let me see here. Let's see if I can. Yeah, it's a public repository, but I do have some permissions on here. All right, I'm going to try and if this doesn't work, we'll probably table this and I'll just demo the process. But it'd be great if this worked. Let's see here. All right, so I don't want to waste your all's time doing this. So if you can try one more time to create a pull request after I disable those two permissions, let me know if you're successful. If not, it might just have to be a visual follow along. No, that's unfortunate. How about this? Well, no, that's not gonna work either. All right. Sorry, I didn't quite have that configured right. But let's go ahead and just work through the process anyways. You'll just have to follow along. Cool, so create the new branch, which if you all had permission to, you would be able to as well. And then from here, there's a command I could run to find out what branches I have. And so if I do git branch -a, that A flag is telling me which ones I have. I don't have the McDev branch, right? And so why might that be? So I created the McDev branch remotely, but then locally, I don't have the McDev branch. Can anyone suggest a command I might be able to run to fix this problem? Pull? Oh yeah, gotcha. Git pull. Let's try that. Run git pull. It's thinking. And I get a message that I have a new branch. It's called McDev. Cool. All right, and so from here, what branch am I currently on in my terminal? Main, right? So if I want to do things on this new branch I created from main, what's the command I could run to switch over to the McDev branch? Checkout. Nice. Git checkout. And then I'll need to say the name of the branch. Cool. And if you notice, my terminal looks different. It says McDev right here. So we've checked out McDev. All right. And then Sorry, my brain blipped out for a second. All right, so now that we have our branch that we're on, let's go ahead and make changes to it. So we'll say code. You can open up the code files however you'd like to. I like using the code command because I have it configured to just pop up in VS Code. I think when you install VS Code, it sets it up for you on Windows users. Mac users, there's an extra step, which is posted in the general channel if you're curious. So from here, we have some HTML. We have a index.html file. We have a CSS file. In our HTML file, we have the HTML element, and within that element is contained the rest of the HTML file. We have our head, which has our metadata. This is also metadata, and right here we're importing our CSS file. Let's see if I can make that more visible. Not really. And then in the body, we have our visible content. And so hypothetically, what we could do is we could add another HTML element. VS Code was helpful, and it just created the closing tag for me. And the name we'll say is aardvark. And I'm going to leave it here. I'm not going to add an ID yet. So if we jump over to this, well, actually, let's pull up this web page real quick. I'm navigating to this just using my file explorer because I just wanted to open up the index.html file. So here we can see with that HTML change, we now have the aardvark text showing up. Now, what happens if I were to say switch over to the main branch? What would happen to my web page? So if I switch over to the main branch and I refresh, what's going to happen? What was that? Will be the same. Will go away. Let's find out. I think I had two different answers on that. So we can see we've modified this file. I say git checkout main. All right. F5. I was expecting that to go away. Let me try to figure out why that happened that way. Okay, gonna add this, commit this. On the McDev branch, git checkout main. Let's try this again. Right, so did any of that just make sense? I moved kind of quickly. I'll narrate what just happened. So we made a change, or I made a change to our HTML. It was on my local machine. I had not committed the file yet. I had not committed it. It was just on my local machine. And so then I switched back over to the main branch. And there was no change per se because I hadn't committed the file. It was just local changes that were just floating out there per se. Now, when I went back to the McDev branch, I committed those changes. So now those changes are saved as part of the branch. And so then when I went back again, those changes disappeared because they were committed. And so the changes that I committed only exist at this point on the McDev branch. So we can see this change in real time. So here we have my VS Code and we have the terminal, and I say git checkout mcdev. And this just popped up. Wasn't there before. Go back to main. Sorry, I'm having a hard time not getting things to cover things up. So I go git checkout main. Disappeared. McDev. See that? And so let me add a third change in there just to see how convoluted I can make this. Save the changes. Running git status, we can see that I've modified the index.html. This is telling me that not just that I modified it, but that I've modified it since the last time I created a commit. So I have uncommitted changes to the McDev branch. So if I git checkout main, so now I get an error, and this is making it a little bit more convoluted. I apologize. But I'm getting an error. I'm trying to switch over to main. And the main branch is concerned that it is going to overwrite my changes when it loads up the index.html file. And so from here, I have two options. I can either git add git commit the changes, and I commit them to the McDev branch before switching, which I will do. Or I could hypothetically just stash the changes, which actually I decided to do that. So git status. Cool. So those changes just disappeared by running git stash. That was the command that was asked about earlier. So run git stash pop, they get added back in. Don't worry about learning the git stash command unless it's interesting for you. It's just an extra little thing there. Git stash. Gone. All right, so apologize. I know this has been a chaotic demo. Jumped around a couple different places, but let's get to this last part here, which is rather important. So if I'm going to commit those changes, or we already have this is committed to the McDev branch. So let's look at a remote repository again. Let's think about what we're expecting to find here. If we look at the HTML file on our main branch, we can see that aardvark is not here. If we switch to the McDev branch, we're probably expecting aardvark to show up, but it doesn't. Why is that? Well, before I show you, someone's gesturing. So we will say git push, because we are pushing changes from our local repository back up to the remote copy. I do that. This requires internet. You can think about git push and git pull. Those are the commands that require internet. Git commit doesn't require internet. And so now that I've pushed those changes up, if I refresh, now I have these changes. And the final thing I want to demo is how to basically combine these two branches, how to combine the McDev branch with the main branch. So the way we can do that is using a pull request. Hypothetically, we could do it locally, but because this is a remote repository, we don't want to do it locally. We want to do it using the pull request process. So it says right here, we have a pop-up message. It says McDev. Notice we're in the pull request tab. It says McDev had recent pushes less than a minute ago. We can press this compare and pull request. It just saves a step right here. I can. This pull request is essentially basically me creating almost like a work order saying like, hey, this is what I've changed. I would like to add this to the main branch. Aardvark. Create pull request. Okay. Right, so this is probably mostly new stuff that we're all seeing here. We've got this pull request. It's got these different tabs. There's a lot going on this page because we have these tabs up top. Then the pull request has its own tabs. But two things that we can zero in on is we have basically the conversation tab is useful, and the files change tab is useful. Clicking on the files change tab from pull requests, and I can see there's a nice visual example of what we're trying to do with the code. And it's saying we would like to take this file and add this line of code. That's what the plus symbol means. And so, let's say there's a team of developers. Someone who's not maybe the person that wrote the code will go into this pull request, look at the file changes. They'll look at this and say, that looks pretty good. I don't think that's going to be any issues. You know, they might test it locally, and so then from there they can review the changes and approve them. Of course, I can't do it because I'm the author of it. But hypothetically, someone else could approve this, submit their review, and then finally, there's a button right here that says Merge Pull Request. When that button is pressed, those suggested code changes, they happen. So that additional aardvark line gets added to the main branch. Right. So a lot happening. It's kind of this whole new workflow concept. But we did just walk through the process as a recap of taking an existing remote repository, pulling it down to the local machine, adding a new branch to the remote repository, pulling that new branch called McDev down to the local machine. We created new changes to the McDev branch by committing those changes. We made the code changes, we saved the code changes, and then we committed those changes. At that point, the changes only existed locally, and so then we had to run the git push command to send that new commit, the new changes up to the remote repository. And then at that point, we had differences between our main branch and our McDev branch. And that is when we entered into this whole pull request workflow, which is kind of its own thing. Awesome. So we're pretty much at time, and we're going to start transitioning over to Studio. Any questions? Yes. Right. So if I was to try to do this locally with git merge, the way this project was originally set up is it would give me an error in saying this is a protected branch. You can't just merge changes into it. Pull request is like a more formalized process. All right, cool. Thank you, everyone.